What if the most advanced eyes humanity has ever built all blinked at the exact same moment, just as something mysterious passed through our cosmic neighborhood? Imagine billions of dollars worth of space technology precision instruments designed to watch the universe with almost supernatural clarity suddenly going silent. No warning, no gradual malfunction, just silence. That is exactly what happened on the 15th of January 2026, when something strange unfolded around the interstellar visitor known as 3I Atlas. The universe often feels like a giant symphony, every star and planet vibrating like strings in an endless cosmic orchestra. Yet on that day, the music seemed to stop. At precisely 18:04 UTC, the Transiting Exoplanet Survey Satellite, better known as TESS, prepared to focus its sensors on the object called 3I Atlas. This spacecraft was built to detect tiny variations in light from distant stars, allowing astronomers to discover planets light years away. It is one of humanity's most precise astronomical tools, but instead of sending back a stream of valuable data, something unexpected happened. TESS didn't simply glitch or slow down. It dropped into deep safe mode, shutting off its data stream completely for 67 long hours. The timing made the event even more unsettling. The shutdown occurred at the exact moment 3I Atlas crossed through sector 1751. The best possible viewing window. Scientists had to observe the interstellar object in detail. This was supposed to be a golden opportunity to analyze its shape, rotation, and behavior. Instead, the satellite went dark. But that wasn't the only strange event that day. Just a few hours earlier, at 14:30 UTC, the International Space Station was suddenly placed into a high-stakes emergency situation. Crew operations were terminated months ahead of schedule. An urgent evacuation order was issued. Official reports described the cause as an unspecified medical emergency that required immediate return to Earth. The crew was quickly deorbited and brought home. Yet, when the astronauts splashed down, every single member was reported to be healthy. For scientists analyzing the situation through theoretical frameworks, such as the scale proposed by physicist Michio Kaku, the coincidence raises an unsettling question. What are the chances that the two most important observation platforms in Earth's orbit would both fail on the same day, within the same 6-7 hour window, while focusing on the same mysterious object? According to statistical mechanics, the probability of these events aligning purely by chance is estimated at roughly 1 in 877,000. That number alone turns an odd coincidence into something far more intriguing. To understand why this matters, it helps to look at how satellites like TESS actually work. Their primary job is to measure tiny dips in light. When a planet passes in front of a distant star, the star's brightness drops slightly. By tracking these light curves, scientists can determine the size, orbit, and sometimes even the atmosphere of planets far beyond our solar system. The same technique can be used to study unusual objects like 3I Atlas. By analyzing the light reflecting from its surface, researchers can estimate its shape, rotation, speed, and possibly its composition. TESS was perfectly positioned to gather this information, but the sudden shutdown erased that opportunity. Some theoretical simulations suggest that a strong localized electromagnetic pulse could trigger a satellite's safety systems without permanently damaging its hardware. Another possibility, discussed in more speculative theoretical models, involves disturbances in higher dimensional physics ideas connected to string theory and the concept of an one-dimensional universe. If either of those scenarios occurred, the result could look exactly like what happened. A complete safe mode shutdown with no permanent damage. This has led some analysts to consider a more unsettling possibility. Instead of a random malfunction, the shutdown could have been caused by a directional jamming event, something deliberately interfering with the satellite's sensors. If a civilization far more advanced than ours existed somewhere in the galaxy, its technology might treat our electronics the way we treat simple mechanical toys. A focused burst of coherent radiation could easily overwhelm delicate sensors and force automated shutdown protocols. Meanwhile, the International Space Station orbits about 420 kilometers above Earth, protected by the planet's magnetic field from most harmful cosmic radiation. In space medicine, a full emergency evacuation of the station is considered an absolute last resort. It is typically reserved for life-threatening situations or catastrophic system failures. Yet the details surrounding that evacuation remain almost completely undisclosed. Some theoretical physicists have proposed another unusual possibility. If 3I Atlas were emitting extremely low-frequency vibrations in spacetime itself, those vibrations might interact with electronic systems or even human neural activity. In such a case, the ISS could unintentionally act like a resonance chamber, amplifying signals from the passing object. If that were true, the evacuation might not have been about a sick astronaut at all. It might have been about shutting down an environment that was suddenly filled with signals humanity doesn't yet understand. And that brings us back to the most important mystery of all, the 6-7 hour gap in observational data. In information theory, sometimes what we don't see is more revealing than what we do. Those missing hours erased our ability to confirm at least 27 unusual features associated with 3I Atlas, from its strange hexagonal surface patterns to its unexplained acceleration that does not match normal gravitational motion. If the object performed any maneuver during those 67 hours, whether a propulsion burst or something even stranger, we would have no visual evidence. We would only see its path before the blackout and its position afterward. In other words, the most important moment of observation occurred precisely when humanity's eyes were closed. And that raises a question that becomes harder to ignore the deeper we look. If the silence was not an accident, then who or what decided it was time for us to stop watching? In the next part, we dive deeper into the 6-7 hour blackout itself, and explore why some scientists believe the silence may have been engineered rather than accidental. If you want to uncover what may have happened while our satellites were blind, make sure you stay with the story and keep watching. In other words, the most important moment of observation occurred precisely when humanity's eyes were closed. And once scientists began analyzing that silence, the situation became even more unsettling. To understand why the 6-7 hour blackout raised quiet alarm inside parts of the scientific community, we have to start with one of the most fundamental rules of physics, the second law of thermodynamics. In simple terms, the universe naturally moves from order toward disorder. Systems break down in messy ways. When technology fails, it rarely fails cleanly. A satellite malfunction usually leaves behind clues, thermal spikes, corrupted signals, sudden voltage changes, or irregular telemetry patterns that engineers can trace, but the shutdown event involving TESS on January 15 did not follow that pattern. Instead of showing a gradual failure or chaotic breakdown, the spacecraft system switched instantly from high-fidelity data transmission to complete silence. No warning, no unstable transition, just a perfect drop to zero. In reliability engineering, this type of clean transition across multiple independent systems is extremely unusual. When two separate platforms experience related failures at the same time, engineers typically begin searching for an external trigger rather than an internal malfunction. And that is exactly what analysts began doing. Looking at the timeline more closely reveals something remarkable. During the calculated orbital convergence with 3I Atlas, the International Space Station happened to be positioned within a direct line of sight of the object's forward trajectory. At the same time, TESS was preparing to collect high-precision optical data from the same region of space. Both platforms, in other words, were perfectly placed to observe the object, and both went offline. One possible explanation comes from the field of electromagnetics. If a sensor system is flooded with a powerful, highly coherent signal, whether microwave, laser, or another form of directed energy, its internal logic can trigger automatic protective shutdowns. These safeguards are designed to prevent permanent hardware damage. From the outside, such an event would look exactly like a sudden safe mode activation. Not a malfunction, a forced reset. This idea has led some theorists to consider the concept of technological suppression. According to models inspired by the Kardashev Scale, a framework describing levels of advanced civilizations, a Type 2 civilization would possess the ability to control enormous amounts of energy. With such capabilities, manipulating electromagnetic signals across planetary distances would be trivial. Under that assumption, the blackout might not have been random interference. It could have been something closer to a deliberate cosmic shush, temporarily silencing nearby observation systems. The statistical evidence supporting this possibility is difficult to ignore. The International Space Station has hosted more than 270 missions throughout its operational history. Early mission termination due to medical emergencies happens in fewer than 2% of cases. Meanwhile, TESS has maintained uptime close to 99% since its launch. Yet both systems experienced disruptions during the exact 6-7 hour period when 3I Atlas was most visible. The calculated probability of that coincidence is roughly 1 in 877,000. In quantum mechanics, when two separate systems display correlated behavior beyond normal statistical expectations, scientists begin to suspect that some form of hidden connection may exist between them. And that possibility opens the door to another question. What exactly happened during the hours we could not see? Some theoretical models suggest that the data gap may have allowed 3I Atlas to activate secondary systems while remaining completely hidden from observation. The object could have altered its trajectory, deployed internal mechanisms, or even changed its physical configuration without being recorded by any of our instruments. But one of the most intriguing aspects of the mystery involves the handling of information itself. All requests made under the Freedom of Information Act for details about the crew 1-1 evacuation have reportedly been denied. From the perspective of information theory, this type of suppressed data, sometimes called dark data, often appears when organizations are dealing with sensitive or potentially disruptive discoveries. One speculative interpretation focuses on radiation exposure. If the object emitted bursts of exotic particles, such as high-energy neutrinos, during its maneuver, the station's protective shielding designed primarily for solar radiation might not have provided sufficient protection. In such a scenario, evacuating the crew would have been the safest immediate response. But there is another layer to the puzzle. When astronomers resumed observation after the blackout, they noticed something strange about 3I Atlas itself. The object appeared to be rotating at a remarkably stable period of approximately 7.1 hours. Maintaining such a steady rotation while performing large trajectory adjustments would normally require advanced stabilization mechanisms. Natural space rocks typically tumble unpredictably. They wobble, drift, and gradually lose rotational consistency over time. 3I Atlas does not appear to behave that way. Instead, it spins with the smooth consistency of a precision gyroscope. In physics, gyroscopic stabilization allows rotating objects to maintain orientation even during large forces or directional shifts. Engineers use this principle in spacecraft navigation systems to maintain stability during complex maneuvers. If something similar is occurring inside 3I Atlas, the object would be far more structurally sophisticated than an ordinary interstellar fragment. And the evidence becomes even stranger when we examine what happened immediately after the 6-7 hour silence ended. When TESS finally rebooted and resumed its observations, the object was no longer following the hyperbolic path predicted by earlier calculations. Its position had shifted dramatically by nearly 300,000 miles, compared with where the trajectory models expected it to be. In classical physics, changing momentum requires energy. Rockets produce heat and exhaust plumes when they accelerate. Even small propulsion systems leave detectable signatures in infrared sensors. But in this case, no plume was detected. No thermal spike appeared in the data. No visible sign of propulsion existed at all. Some theorists have suggested a far more radical explanation based on concepts from string theory. Instead of moving through space using conventional propulsion, the object might be manipulating the geometry of spacetime itself. If it could momentarily slide through higher dimensional space, the transition would bypass the friction and energy losses associated with normal motion. From our perspective, it would look as if the object simply jumped from one position to another. The implications of that possibility are enormous. It would mean the object is not just traveling through our solar system, it is using physics that humanity is only beginning to theorize about. And if that is the case, the 6-7 hour silence might not have been a technical failure at all. It may have been the perfect moment for something to move while no one was watching. In the final part of this investigation, we examine what happened when the silence ended and why the signal that followed may suggest that 3I Atlas was not merely passing through our system, but actively interacting with it. If you want to understand what scientists believe may have happened next, make sure you stay with us and continue watching. It may have been the perfect moment for something to move while no one was watching. And when the silence finally ended, the data that returned raised an even deeper mystery. At the exact moment the 6-7-hour blackout concluded, something unusual appeared within the deep space monitoring networks. Instead of the normal background chaos that fills the vacuum of space, sensors detected a coherent resonance coming from the coordinates where 3I Atlas had just completed its unexplained maneuver. To understand why that matters, we have to look at the science of signal processing. In nature, most signals are messy. Random fluctuations, interference, and noise dominate the electromagnetic environment of space. Stars flicker, radiation scatters, and cosmic particles constantly disrupt patterns. But a coherent resonance is different. It maintains a stable phase and frequency over time. That kind of signal is typically associated with engineered systems. In other words, it behaves like a transmission. When analysts first noticed this resonance, it immediately raised questions about what might have happened during the blackout. If the signal was artificial, then the 6-7-hour silence may not have been an accident or even a maneuver. It could have been part of a larger process, something closer to a handshake between the object and the surrounding environment. Some theoretical models suggest that the blackout may have functioned like a system reset for the local region of space. Instead of merely hiding its activity, the object may have been altering the conditions around it to prevent detection by our sensors. If we consider technological civilizations far more advanced than our own, this possibility becomes less impossible than it sounds. A civilization capable of controlling planetary scale energy could manipulate local space-time conditions the way modern engineers manage computer networks. In that context, the blackout might resemble something unexpected. A software update applied not to a computer, but to an entire region of space. To see why scientists began exploring this idea, we need to examine the gravitational data recorded after the event. Under normal circumstances, an object's gravitational influence corresponds directly to its physical location. In general relativity, mass curves spacetime, and that curvature reveals where the mass exists. But after the January 15 convergence, the gravitational footprint of 3I Atlas appeared to drift slightly away from the object's visible position. In simple terms, the gravity signature and the object itself no longer perfectly aligned. One explanation for this phenomenon involves a concept called frame dragging. According to Einstein's theory of general relativity, massive rotating bodies can twist spacetime around them as they spin. This effect has been observed around extremely dense objects such as neutron stars and black holes. Yet the data suggests that something similar may be happening around 3I Atlas on a much smaller scale. If the object is spinning rapidly enough, and if it possesses the right internal structure, it could be generating localized distortions in spacetime that shift the apparent position of its gravitational field. That would allow it to appear somewhere slightly different from where it truly is. The implications of this are profound. It would mean that our telescopes might not be seeing the object directly, but rather a warped projection created by the distortion around it. And the mystery deepens when we examine Earth's own magnetic environment during the same time window. Magnetospheric monitoring stations recorded a series of unusual magnetic twists known as flux ropes, structures normally associated with powerful solar storms. These events occur when magnetic field lines become tangled and suddenly reconnect, releasing bursts of energy. But on January 15, the sun was quiet. There were no solar flares, no major coronal mass ejections, nothing that could explain the disturbances. That has led some researchers to speculate that the magnetic fluctuations may have been triggered by the presence of 3I Atlas itself. If the object interacted with Earth's magnetosphere, either intentionally or as a side effect of its own systems, it could have created the flux rope patterns detected by monitoring instruments. Some models even suggest the object could be drawing energy from magnetic fields to power its own internal processes, similar to how spacecraft sometimes harvest solar energy. Viewed through the lens of quantum mechanics, this possibility becomes even more intriguing. At extremely small scales, particles and forces are interconnected in ways that still challenge our understanding. Fields, energy, and matter constantly interact across distances. If 3I Atlas is operating with technologies based on these principles, it might be treating our planet, our star, and the surrounding space as components of a larger system, almost like a circuit, and that realization leads to a deeply unsettling question about our current understanding of observation. In astronomy, we usually assume that what we see in space reflects physical reality. Telescopes gather light, sensors measure radiation, and we interpret the results as accurately as possible. But the 6-7-hour silence introduced a new possibility. What if we only see what the object allows us to see? In that scenario, humanity is no longer the primary observer in this situation. Instead, we may be part of the experiment itself. The object's consistent 7-1-hour rotation. Its steady, clock-like rhythm remains one of the few reliable patterns in the entire dataset. Everything else around it appears to shift and change. From the perspective of game theory, probes are often used to test unknown systems. They gather information, identify weaknesses, and map the boundaries of an environment before larger actions are taken. If 3I Atlas is functioning as a probe of some kind, then the events surrounding the blackout may have revealed something important. It may have learned exactly how far our detection systems can reach. It may now understand how quickly we respond to unexpected events. And it may know how easily our observational infrastructure can be disrupted. That possibility changes the entire context of this encounter. Instead of a passive interstellar object drifting through our solar system, we might be dealing with something that is actively evaluating the civilization it has encountered. For now, the only constant remains the object's slow, deliberate rotation, like the steady ticking of a cosmic clock. A 3 billion ton mystery spinning silently through our neighborhood, capable of blinding our instruments whenever it chooses. The universe has always been filled with music, the endless vibrations of matter and energy playing across space-time. But the events surrounding January 15 suggest that someone else may now be holding the conductor's baton, and humanity is listening, unsure of what the next note will be. If you found this investigation fascinating and want to explore more deep cosmic mysteries like this one, make sure to like the video, subscribe to the channel, and turn on notifications so you never miss the next discovery that could change how we see the universe.